Good day to all of us. We can see on the board we are through with the algebraic processes involving modular arithmetics, and as we can see, we are now on equations involving modular arithmetics. The good thing here is that if you've been following this particular page or channel on YouTube, page on Facebook, by now you've mastered, I believe you've mastered division, addition, subtraction, and multiplication involving modular arithmetic. So getting to the equation, there's no cause for alarm. I know you've mastered all what is required to solve equation involving modular arithmetic. But if you are just joining us and you don't have a sound knowledge, especially on division involving modular arithmetics, watch our previous video, click the modular arithmetic series / circular variable. Watch each of the video, you will get yourself to this point where you have no problem. Then for those that have been following us, let's quickly dissect this. Solution to the first question. It says 3x is congruent to what or equal to what? 1 mod 7. So the unknown here, mathematics student, we already know the unknown here is what? X. And remember in modular arithmetics, for you to isolate the unknown, you have to look for inverse of the coefficient. Because here you can say divide both sides by 3. Why? You are working with what? Mod 7. So you can't do algebraic division here. You have to follow modular arithmetic division. So you need to look for the multiplicative inverse of this. Now, how do you get it? What do we mean by the multiplicative inverse? For clarity's sake, we mean what can give us what? What we can use to multiply this 3s. Let's say to multiply 3s, that will give us what? 1 mod 7. That's what we are talking about. So how do we get it? We have to check. 3 times 1. 3 times 1 is what? 3. 3 times 2, 6. 3 times 3, 9. Now, 7 and 9, 1 remainder 2. It's going to give us 3 times 4 is 12. 7 and 12, 1 remainder 5. 3 times 5, that is 15. 7, 15 is 1 remainder 1. So this is what will give us 1 mod 7. So the inverse of 3 inverse of 3 here under this moduli is 5. So multiply through by 5. Or to save space, we've already seen how to get the inverse. So we can say 3 inverse x times 5 is equals to what? 1 times 5 mod 7. This inverse will take this one away as we showcased. The multiplicative inverse of 3 is 5 under modular 7. So we have x equals to 5 mod 7. This is our answer. Now, let's check second question. If you can check very well, you see that the modular here is very high. So definitely it means that what? The inverse at the end of the day of this 7 is going to be a high number. Because if it's not going to be a high number, there's no reason why they will put 26 as modular in this question. This is just what? A hint as a student or as a teacher to know where you are heading to. Now, let's solve the question. 7k equals to 9 mod 26. And we are looking for what? K, because it's our unknown. Now, how do we get k? In normal algebra, you say divide both sides by what? 7. You can't do that here because you are working under the restriction or constraint of modular 26. So you have to follow the order. Now, the only way to isolate our k is to find the multiplicative inverse of 7. That means a number that would divide this 7 and turn everything to what? 7k times such number will now give us 1 mod 26. That's the only way we can isolate k. So let's check 7 times what? 1 is 7. It doesn't hold water here. 7 times 3 is 21. It does not affect because it's lower than 26. Now, 7 times 4 is 28. 26 and 28 is 1 remainder 2. Remember, this is what you are looking for. 1 mod 26, not 2 mod 26. Now, 7 times, let's say 7 is 49. Divided by 26, it gives you 1 remainder like 22. You're not close because it is the remainder that what? Need. Let's say 7 times 10, 70 divided by what? 26. 26 divided by 26, let's use our calculator to save time. You still give you 2, remainder 18. And we are looking for remainder 1, so we are not close. 7 times 12 is 84. 26 times 3, 78. So this one gives us 3 remainder what? 6. So we have to check, let's say 7 times 14. 7 times 14, we have 98. Divided by 26, what will it give us? We have 3. 26 times 3 is 78. 98 from 78 gives you what? 3 remainder 20. Far from it. Check 7 times 15. That's 105, if I'm not mistaken. 105 divided by the moduli here. 105 divided by 26 gives us what? 4. Remainder what? Okay. 26 times 4. Beautiful. This is what? 4 remainder 1. This is what we are looking for. So it means the inverse of 7 under moduli 26 is 15. So we can come here now and say 7k times 15 equal, multiply through by 15. Let's rewrite our question. 7k equals to what? 9 mod 15. So multiply through by 15. So you have 7k times 15, which is equals to what? 9 times 15 mod 15. Now 9 times 15 is 135. Let's make use of this, guys. So you have, since 15 is inverse of 7 this, so this one we cancel this. You have k is equal to what? 135 mod 26. Now k is equals to what? 135 divided by 26. 5. 126 times 5. 26 times 5. 130. So you have what? 26 times 5 plus 5 mod 26. Therefore, k equals to what? 5 mod 26. Now, let's check. Since k is 5, check. You have what? 7k equal to 9 mod 26. That is 7k mod 26. 7 times 5 is 35 mod 26. Now, 26 in 35. That gives you 1 remainder 9. That is 9 mod 26. Therefore, this confirms that what? The value of k is actually 5. Before we go, I'm going to give you this as what? A try. Try this. We have, let's say we have 8y equal to 6 mod 13. Solve. Drop your answer in the comment section. If it has solution, give us the solution. And if it does not have, show us your workings and make a conclusion on what? On the question. Don't forget to follow us on our social media handle, Aminu Maths Class on Facebook page, so also on YouTube, on Instagram, the same name on TikTok. Thank you for following us. Be with us and enjoy more questions on this topic and what next topic that we'll be doing. Thank you and bye-bye for now.